Hello there and welcome to the Sleepy Echoes channel. I'm so glad you found your way here because tonight we'll be drifting through the quiet wonders of space, through trails of ice and ancient dust, through the gentle wanderers we call comets. Wherever you are in the world, let this be your moment to slow down. Let the noise soften, the edges blur and your thoughts settle like stardust on velvet darkness. Tonight we're traveling beyond Earth but not too far. Just far enough to watch the slow dance of comets as they glide through the solar system, carrying secrets from the birth of our cosmic neighborhood. These frozen travelers have inspired wonder for thousands of years, and tonight they'll guide you gently toward rest. Some of what you hear may change how you see the night sky. Other discoveries might simply float by like whispers on a breeze, gentle, curious, and quietly unforgettable. If this kind of peaceful wonder brings you calm or sparks your curiosity, consider liking and subscribing. It helps others find their way here too, one sleepy soul at a time. But for now, let yourself get comfortable. Take a deep breath, and let's begin this slow and soothing journey through the tranquil realm of comets. Comets are ancient time capsules from the birth of the solar system, 4.5 billion years ago. When the sun was young and the planets were still forming, something remarkable happened. Not everything became a planet. Some material, ice, rock, dust, and frozen gases drifted to the outer edges of the solar system and stayed there untouched, unchanged, waiting. These are comets. They are fragments of the solar system's infancy, preserved in the deep freeze of space. While planets evolved, shifted, and transformed, comets remained the same, locked in cold storage beyond Neptune, beyond Pluto, in regions so distant that sunlight barely reaches them. When scientists study a comet, they're looking back in time. They're examining the original ingredients that made our sun, our planets, and perhaps even life itself. Every comet is a library, a record written in ice and stone, holding stories older than mountains, older than oceans, older than Earth itself. The materials locked within their frozen bodies have remained virtually unchanged since the solar system's birth, making them some of the most pristine objects we can study. While Earth has been shaped by volcanoes, erosion, plate tectonics, and life itself. While Mars has lost its atmosphere, while Venus has been transformed by runaway greenhouse effects, comets have simply waited in the cold, dark reaches of space, preserving their secrets. These ancient wanderers come from two main regions in our solar system. Some originate from the Kuiper Belt, a disc-shaped region beyond Neptune filled with icy bodies. Others come from even farther away, from a vast spherical cloud called the Oort cloud, which surrounds our entire solar system like a bubble. The Oort cloud is so distant that it takes sunlight more than a year to reach its inner edge. Out there in that frozen darkness, trillions of comets drift in slow, patient orbits, some barely moving at all, suspended in the space between our sun and the nearest stars. Every so often, something disturbs one of these sleeping travelers. Perhaps a passing star tugs on it with gravity. Perhaps another comet bumps it gently. Perhaps the subtle gravitational dance of the giant planets shifts its path just enough. And then, after billions of years of stillness, the comet begins to fall inward, drawn by the sun's distant gravity, beginning a journey that may take thousands or millions of years. As it falls, it accelerates, moving faster and faster, until finally it sweeps through the inner solar system. Warmed by the sun for perhaps the first time since it formed, glowing briefly in our skies before returning to the darkness, or perhaps never returning at all. The chemistry locked inside these frozen time capsules tells us about the conditions in the early solar system. The ratios of different isotopes, the types of minerals present, the organic molecules frozen in the ice, all of these are clues to how our cosmic neighborhood formed. Scientists have found that comets contain water with a slightly different chemical signature than Earth's oceans, which tells us that while comets may have contributed some of our water, they probably weren't the only source. They found complex organic molecules, the same kinds of carbon-based compounds that are essential for life, suggesting that the building blocks of biology may have been scattered throughout the solar system from the very beginning. Some comets are making their first trip into the inner solar system, virgins that have never felt the sun's warmth. These are especially precious to scientists because they are the most pristine, the least altered by heat and radiation. When such a comet appears, astronomers around the world turn their telescopes toward it, eager to glimpse this messenger from the dawn of time. Other comets are veterans, returning again and again on predictable schedules, slowly losing their ice with each passage near the sun, gradually transforming from active, glowing travelers into dark, dead rocks that no longer respond to the sun's heat. And so tonight, as you rest, imagine this. Somewhere far beyond the moon, beyond Mars, beyond everything familiar, ancient travelers wait in the dark, patient and still, carrying the memory of a time before time. They are not rushing. They are simply there, drifting, quiet, eternal. They have witnessed the entire history of our solar system from the outside. Silent observers to the formation of planets, the birth of moons, the evolution of life on Earth. They were there when the first single-celled organisms appeared in Earth's oceans. They were there when dinosaurs walked. They were there when humans looked up at the stars and began to wonder. And they will be there long after we are gone, still drifting, still waiting, still carrying their ancient messages through the endless dark. Comets are made mostly of ice dust and frozen gases. If you could hold a piece of a comet in your hand, it wouldn't feel like a rock. It would feel cold, yes, impossibly cold, but it would also feel soft in places, crumbly, almost delicate, because comets are not solid stone. They are mixtures, blends of water ice, carbon dioxide, methane, ammonia, and tiny grains of dust and rock all frozen together. Scientists sometimes call them dirty snowballs, though that feels too simple for something so ancient. Others prefer icy dirt balls, which is closer to the truth. They are fragile, porous, held together more by cold than by strength. Some comets are so loosely packed that if you could stand on one, you might sink slightly into the surface, like stepping onto soft snow. The structure of a comet is more like a sponge than a solid boulder. Imagine Swiss cheese made of ice, filled with countless tiny pockets and gaps with dust and rock mixed throughout. The density is often less than that of water, which means these objects would actually float if you could find an ocean large enough to hold them. This porous structure forms because comets are not born from molten rock that cooled and solidified, like planets and moons. Instead, they formed from the gentle accumulation of ice and dust particles in the outer solar system, materials that simply stuck together in the cold, never compressed by heat or pressure into something more solid. The ice in a comet is not just water ice, though water ice is the most abundant component. Mixed throughout are other frozen substances that would be gases at room temperature. Carbon dioxide frozen into dry ice, methane, the same gas that burns in stoves and heaters, ammonia, pungent and reactive, carbon monoxide, silent and deadly in confined spaces but here locked safely in ice. These frozen gases are called volatiles because they evaporate easily when warmed, and it is their transformation from solid to gas that creates the spectacular displays we see when comets approach the sun. Embedded throughout this icy matrix are grains of dust and rock, some no larger than particles of smoke, others as big as pebbles. These solid particles are made of silicates, the same minerals that form much of Earth's crust, along with carbonaceous materials, organic compounds rich in carbon. The dust grains themselves are ancient, some of them predating the solar system itself, formed in the atmospheres of dying stars and blown into space, eventually finding their way into the cloud of gas and dust that collapse to form our sun and planets. When you look at a comet's dust under a microscope, you are looking at grains that may be older than the sun, visitors from other stellar systems, incorporated into our solar system's formation. Inside this frozen matrix are organic molecules, carbon-based compounds, the building blocks of life. Not life itself, but the ingredients. Amino acids, the molecules that link together to form proteins. Sugars, the basis of RNA and DNA. Complex hydrocarbons, chains and rings of carbon atoms that form the foundation of organic chemistry. All locked in ice, waiting. When a comet warms, these molecules are released, drifting into space, perhaps landing on young planets, perhaps planting the seeds of something new. Some scientists believe that comets may have delivered not just water, but also the organic chemistry necessary for life to begin on Earth, and perhaps on other worlds as well. The surface of a comet, when you see it up close, is darker than you might expect. Despite being made mostly of ice, comets are actually quite black, darker than coal in many cases. This happens because over time, as comets orbit the sun and lose their surface ice to sublimation, the dust and organic materials are left behind, forming a dark crust that covers much of the surface. This crust acts like a blanket, insulating the ice beneath, slowing the rate of evaporation. But the crust is not perfect. It cracks and breaks, allowing jets of gas and dust to burst through when the comet is heated by the sun, creating the dramatic geysers and outbursts that spacecraft have photographed up close. So as you breathe slowly and let your body relax, picture this. A comet is not just ice. It is potential. It is chemistry waiting to awaken. It is the universe's way of preserving possibility, one frozen traveler at a time. Each comet carries within it the raw materials for oceans, atmospheres, and perhaps even life itself. They are delivery vehicles, cosmic shipping containers that have been carrying precious cargo across the solar system for billions of years. And they are still out there, countless numbers of them, drifting in the cold, dark places, each one a unique blend of ice and dust and organic chemistry. Each one a gift waiting to be opened, a story waiting to be told. A comet's tail always points away from the sun. There is a quiet beauty in the way a comet moves through space. As it journeys inward, drawn by the sun's gravity, something magical begins to happen. The ice starts to warm, not much but enough. And as it warms, it doesn't melt. It sublimates, turning directly from solid to gas, skipping the liquid phase entirely. This gas, along with dust, streams away from the comet's surface, forming a glowing cloud called a coma, and then a tail. But here's the gentle, elegant truth. A comet's tail doesn't trail behind it like hair in the wind. It always points away from the sun, no matter which direction the comet is traveling. Why does this happen? Because the tail is not shaped by motion. It's shaped by light. The sun doesn't just shine, it also pushes. Photons of light carry momentum, and when they strike dust particles or gas molecules, they impart a gentle but persistent pressure. This is called radiation pressure, and while it's too weak to affect anything as massive as a planet or even a spacecraft, it's more than strong enough to push the tiny particles that make up a comet's tail. At the same time, the sun emits a constant stream of charged particles, electrons and protons, racing outward at hundreds of kilometers per second. This is the solar wind, an invisible river that flows from the sun in all directions, filling the solar system. When the solar wind strikes the gas molecules in a comet's coma, it ionizes them, stripping away electrons, and then sweeps these charged particles outward, away from the sun. So sometimes, when a comet is leaving the inner solar system, traveling back toward the cold, dark reaches from which it came, it actually travels tail first, as if backing gracefully out of a room. The comet's head points away from the sun, but the tail, always obedient to the pressure of light and the rush of the solar wind, streams ahead of it. This creates one of the most counterintuitive and beautiful sights in astronomy, a celestial traveler moving in one direction, while its glowing banner points in another. There are actually two tails, and if you look carefully at a bright comet, or photograph it with the right equipment, you can see both. One tail is made of gas plasma, ionized molecules that glow with a characteristic blue color. This is the ion tail, and it is straight and narrow, pointing directly away from the sun like an arrow. The molecules in this tail, mostly carbon monoxide and nitrogen, have been energized by ultraviolet light from the sun, and they emit their own light as their electrons jump between energy levels. The ion tail responds quickly to changes in the solar wind, sometimes developing kinks and disconnections when the wind is gusty, when solar storms disturb the steady flow. The other tail is made of dust, tiny solid particles pushed away from the comet by the gentle pressure of sunlight. This dust tail is broader and more diffuse than the ion tail, and it curves gently because the dust particles have mass and follow orbital paths, affected both by the sun's gravity and the pressure of light. The dust tail glows with reflected sunlight, appearing white or yellowish, and it can stretch for millions of kilometers, though its light is spread out and faint. Sometimes a comet will have a third feature, an anti-tail which appears to point toward the sun. This is an optical illusion caused by large dust particles that lie in the orbital plane of the comet, seen edge-on from Earth, but the true tails always point away. Both tails are whispers, breaths of a comet exhaled into the void, lit softly by distant firelight. They are impermanent, temporary, existing only when the comet is near enough to the sun to be warmed, usually inside the orbit of Mars. When the comet ventures back into the cold outer solar system, the sublimation stops, the gas and dust settle or dissipate, and the tails fade away. The comet returns to being a dark, frozen nucleus, silent and invisible, waiting for its next approach to the warmth and light, And as you settle deeper into rest, imagine that tail stretching across the sky, silent, luminous, always turning away from the light, always flowing, always free. Picture the delicate dance of physics and chemistry that creates this spectacle. The interplay of heat and cold, light and matter, gravity and pressure. A comet's tail is not a thing but a process, not an object but an event, a visible manifestation of invisible forces. A gentle reminder that even in the vacuum of space, nothing is truly still, everything flows, and beauty emerges from the simplest laws of nature. Playing out on the grandest stages, comets can have orbits that take thousands or even millions of years. Time moves differently for comets. While we count our lives in decades, comets count theirs in eons. Some comets, called short-period comets, visit the inner solar system every few years or decades. Halley's Comet, for instance, returns every 76 years, like a patient friend checking in once a lifetime. It graced the skies in 1986, and it will return again in 2061, a celestial appointment keeper that spans human generations. Those who saw it as children might see it again in old age, bookending a lifetime with the same wandering visitor. But others, long-period comets, take a different path entirely. They travel to the farthest edges of the solar system, into a vast spherical cloud of icy bodies called the Oort cloud, a region so distant it takes more than a year for sunlight to reach it. This cloud exists in a realm of near-total darkness, a freezer at the edge of the sun's gravitational influence, stretching halfway to the nearest star. These comets may take thousands, tens of thousands, even millions of years to complete a single orbit around our sun. Imagine that. A comet that last passed Earth when mammoths walked the land, when humans were just learning to paint on cave walls, when the stars overhead were arranged slightly differently than they are today. A comet that won't return until civilizations we can't imagine have risen and fallen, until languages we'll never hear have been spoken and forgotten, until the continents have shifted and the coastlines have changed. A comet that moves so slowly through the outer dark that its journey is not measured in human time, but in the time of stars, in the time of species rising and going extinct, in the time of mountains forming and eroding away. Some of these comets are making their very first trip inward, disturbed from their distant slumber by the gravitational nudge of a passing star or the subtle pull of a giant planet. For millions or billions of years, they've hung motionless in the black, barely moving, frozen in the ultimate deep freeze. Then something shifts. A star passes within a light year or two, its gravity reaching out like an invisible hand, giving the comet the gentlest push. And slowly, over thousands of years, the comet begins to fall. It falls toward the sun, perhaps for the first and only time, picking up speed as it descends through the planetary orbits, glowing briefly, beautifully as it passes through the inner solar system, and then returning to the dark forever. These first-time visitors are special. They're pristine, untouched by previous encounters with the sun's heat. Their surfaces haven't been weathered by repeated warming and cooling. They carry their original ice, their original chemistry, unchanged since the solar system's birth. When astronomers spot a comet on a hyperbolic orbit, one that will pass the sun once and then leave the solar system entirely, never to return, there's a bittersweet quality to the observation. It's a once-in-forever event. That particular traveler will never again see our sun. The mathematics of these orbits is elegant. The closer a comet comes to the sun at its nearest point, called perihelion, the faster it moves. But as it climbs back out into the cold darkness, heading toward its farthest point called aphelion, it slows down. At the very edge of its orbit, billions of miles away, it's barely moving at all, hanging in space, balanced between falling back and drifting away. It might spend thousands of years out there at that distant point, moving so slowly that its position barely changes from year to year, century to century. And so tonight, let your mind drift with them. There is no hurry. There is no rush. Time stretches long and soft, and somewhere far away a comet glides in silence, taking all the time in the universe. It's not late. It's not early. It simply is, moving through the dark on its own schedule, utterly indifferent to the brief, bright lives of the planets it occasionally visits. While we measure time in minutes and hours, while we rush and plan and worry about tomorrow, these ancient travelers remind us that the universe operates on timescales that make human concerns seem like the flutter of a butterfly's wing. There's a profound peace in understanding this. The comet doesn't stress about its long journey, It doesn't wonder if it will arrive on time. It simply follows the path that gravity has laid out for it, patient beyond measure, steady beyond comprehension. In millions of years, when the comet next approaches the Sun, everything about Earth will be different except perhaps the Sun itself and the mathematics that govern the comet's path. Different species, different atmospheres, different arrangements of ice and water and land. But the comet will return, following the same invisible rails through space that it's followed for billions of years, a cosmic metronome keeping time on a scale we can barely imagine. The nucleus of a comet is surprisingly small. When you see a comet in the night sky, it looks enormous. A glowing head, a sweeping tail stretching across half the heavens, sometimes spanning 30 degrees of sky or more. It feels vast, cosmic, larger than imagination. From horizon to horizon, the tail might reach, a luminous banner written across the dark. It feels like you're witnessing something planetary in scale, something that must be massive beyond comprehension, to be visible from Earth, to dominate the sky so completely, to inspire such awe. But here's a secret, a quiet truth that makes the spectacle even more remarkable. The solid part of a comet, the nucleus, the actual body of ice and rock at its heart, is often no bigger than a small mountain. Some are just a few kilometers across, others only hundreds of meters, smaller than some cities, smaller than some lakes, smaller than the distance you might drive in a few minutes on a highway. If you could somehow stand it next to a large building, you might be able to walk around it in an hour or two. The Great Comet of 1996, Hale-Bopp, which dazzled millions and remained visible to the naked eye for a record-breaking 18 months, had a nucleus only about 40 kilometers wide. That's roughly the size of a small county, the distance you might cover in a half-hour drive. Yet this relatively tiny object put on one of the greatest celestial shows in modern history, visible even from light-polluted cities, bright enough to cast shadows on a dark night. With a tail that stretched across a significant portion of the sky, Halley's Comet, famous for centuries, recorded in historical documents dating back more than 2,000 years, is just 15 kilometers long and 8 kilometers wide, about the size of a small city or a large island. You could fit it inside some metropolitan areas, and yet when it approaches the Sun, its coma, the cloud of gas and dust that surrounds the nucleus, can swell to 100,000 kilometers across, larger than the planet Jupiter, larger than anything in the solar system except the Sun itself. Its tail can stretch for millions of kilometers, sometimes reaching all the way to Earth's orbit, even when the comet itself is much farther away. It's a magic trick of light and physics, one of nature's most impressive illusions. A tiny frozen stone becomes a giant made of glow and gas, visible across the solar system, bright enough to be seen from Earth without any optical aid at all. The nucleus itself is dark, almost black, covered in a crust of dust and carbon, formed by millions or billions of years of radiation exposure. Its surface is darker than coal, darker than asphalt, reflecting only about 4% of the light that hits it. If you saw one up close without the sun's light, floating in the dark like a massive charred potato, it would look more like an asteroid than the gleaming ice ball you might imagine. The nucleus is also surprisingly fragile. It's not solid ice or solid rock, but a loose mixture of both, more like a pile of frozen rubble than a single solid object. Some scientists describe the structure as being like a sponge, full of pores and voids, held together weakly by ice that acts as a sort of glue. If you could somehow stand on the surface of a comet nucleus, you might find yourself sinking slightly, like standing on deep snow or sand. The gravity would be negligible, so weak that a good jump might send you floating off into space, never to return, but distance and sunlight transform it entirely. When the comet approaches the Sun and begins to warm, jets of gas burst from the surface, carrying dust with them. These jets can be surprisingly powerful, strong enough to actually change the comet's rotation or slightly alter its orbit. The gas and dust form a glowing cloud lit by sunlight that grows larger and larger as the comet gets closer to the Sun. The small becomes vast, the hidden becomes radiant, the darkness becomes light, and from Earth we see not the thing itself but its breath, its aura, the soft light it releases as it warms. We see the atmosphere it creates, the temporary transformation from frozen rock to glowing spectacle. The tail we admire is nearly a vacuum, so diffuse that you could pass through it and barely notice. It's mostly empty space with a scattering of dust and molecules, but it catches the sunlight and glows, and that's enough. That's what makes it visible across millions of kilometers. And as you close your eyes, think of this. Even the smallest things, when touched by light, can fill the sky. A mountain-sized rock, dark and cold, becomes a beacon visible across the solar system. It reminds us that size isn't everything, that visibility doesn't require vastness, that sometimes the greatest shows come from the smallest sources, transformed by circumstance, by light, by the gentle touch of warmth into something unforgettable. Comets helped bring water to Earth long ago. When Earth was young, it was a molten, hostile world. Volcanoes erupted continuously, spewing lava across the surface in rivers of liquid rock. The air was toxic, filled with carbon dioxide, sulfur dioxide, and other gases that would be instantly lethal to any form of life we know today. The surface was too hot for water to stay liquid or even solid. Any water that existed would have immediately boiled away into steam, lost to space, or locked away deep underground. And yet today, oceans cover more than 70% of our planet's surface, holding about 1.4 billion cubic kilometers of water, enough to fill countless swimming pools, enough to create weather, to sustain forests, to fill rivers that carve canyons, to make Earth the blue marble we recognize from space. Where did all that water come from? This question has puzzled scientists for decades, and the answer they've arrived at is both surprising and beautiful. Some of it came from within Earth itself, released from rocks and minerals as the planet cooled and solidified. Water was trapped in the crystal structures of minerals, and as the Earth's interior churned and convected, as volcanoes erupted, that water was gradually released to the surface, molecule by molecule, eruption by eruption, over hundreds of millions of years. But much of it, perhaps most of it, was delivered from space, by comets and by asteroids, over millions of years. During a period called the Late Heavy Bombardment about 4 billion years ago, these icy travelers crashed into the young Earth by the thousands, perhaps by the millions, bringing with them vast quantities of water, locked in ice, released on impact. Each collision was violent, releasing energy equivalent to multiple nuclear weapons, vaporizing rock, creating massive craters, sending shockwaves around the planet. But each collision was also a delivery, a gift wrapped in ice and stone. Each comet was carrying water that had been frozen for billions of years, since before the solar system had fully formed. Water that had never been liquid, that had never flowed, that had never known warmth. And when these comets struck Earth, that ice was suddenly and violently transformed. Some of it vaporized immediately, becoming steam rising into the atmosphere. Some of it melted, becoming liquid for the first time in its existence, pooling in the crater, mixing with molten rock, eventually cooling and flowing across the surface. A comet is mostly water ice. A typical comet might be 60 to 80% water by mass, which means a comet just 10 kilometers across could deliver trillions of tons of water in a single impact. Multiply that by thousands or millions of impacts over hundreds of millions of years, and you begin to understand how Earth's oceans were filled. Drop by drop, impact by impact, comet by comet, the water accumulated. Each impact, though violent, was also an act of creation. The same forces that scarred the surface also filled it with the ingredient for life, the medium in which chemistry could happen, in which molecules could move and interact and eventually organize themselves into something alive. Some scientists believe comets also brought organic molecules, the chemical precursors to life. Not life itself, but the ingredients, the building blocks. Carbon compounds, nitrogen compounds, amino acids, which are the building blocks of proteins, sugars, which are the building blocks of DNA and RNA, complex hydrocarbons, all the alphabet of biology. These molecules are surprisingly common in comets. When scientists analyzed samples returned from Comet Wild 2 by the Stardust mission, they found glycine, the simplest amino acid, along with a host of other organic compounds. If this is true and the evidence is growing stronger, then comets are not just messengers from the past, not just frozen time capsules. They are gardeners, sowing seeds across the cosmos, planting the possibility of life wherever they land. Every comet that strikes a planet is potentially delivering the ingredients for life, dropping off a care package from the outer solar system, giving that planet a chance, a starting point, a foundation to build on. This process isn't unique to Earth. It's happening throughout the solar system and presumably throughout the galaxy. Comets strike planets and moons regularly, delivering water and organics. Some of Jupiter's and Saturn's moons are covered in water ice, possibly delivered by comets long ago. Mars once had liquid water on its surface, possibly delivered the same way Earth's was. Even today, comets occasionally strike planets in our solar system, and we've witnessed it, like when Comet Shoemaker-Levy 9 broke apart and crashed into Jupiter in 1994. So tonight, as you rest beneath blankets, as you breathe and soften, remember this: the water in your body, the water that makes up about 60% of your mass, the water you drank today from a glass or bottle, the water in your cells right now allowing them to function, may have once been ice, drifting in the dark outer reaches of the solar system, carried here by a comet billions of years ago. You are made in part of their gift. You are partially comet. The ocean inside you was delivered from space, frozen and dark and ancient, now warm and alive and aware, thinking about its own origins, made of stardust and comet ice, connected to the cosmos in the most literal and beautiful way possible. Some comets break apart as they approach the sun. Not all comets survive their journey. The sun is beautiful, but it is also fierce. As a comet draws near, the heat intensifies. Ice turns to gas, dust lifts away, and sometimes the stress is too much. The comet begins to crack. It might split into 2 pieces, then 4, then more. Each fragment continues forward, glowing, trailing its own small tail. A family of travelers now scattered. Some break gently, almost gracefully. Others shatter suddenly, bursting into clouds of dust and steam that catch the sunlight and glow like ghosts. The breaking of a comet is not instantaneous. It happens gradually over days or weeks, as the nucleus heats unevenly. One side might be facing the sun, warming rapidly, while the other side remains frozen. This creates stress, thermal stress, like what happens when you pour hot water into a cold glass. The material expands on one side and contracts on the other, and something has to give. Cracks form, running through the ice and rock, spreading like lightning through the fragile structure. Gas builds up beneath the surface, pressure mounting, until finally something breaks free. When a comet splits, each piece becomes its own small comet, following nearly the same path as the original, but now separate, distinct. Sometimes these fragments stay close together, forming a string of glowing pearls across the sky. Other times they drift apart, each going its own way, each with its own tail, its own coma, its own brief moment of glory before it too might break again or fade into darkness. In 1994, astronomers watched as Comet Shoemaker-Levy 9 broke into more than 20 pieces before colliding with Jupiter. This was no ordinary breakup. The comet had passed too close to Jupiter on a previous orbit, and the planet's immense gravity had torn it apart, pulling it into fragments like bread being torn by invisible hands. Each fragment struck the giant planet over the course of a week, creating explosions larger than Earth, dark scars that lasted for months. The impacts released energy equivalent to millions of nuclear weapons, sending shockwaves through Jupiter's atmosphere, creating temporary holes in the clouds that telescopes could see from Earth. The comet gave its life in a final, spectacular display, and humanity watched, witnessing for the first time what happens when a comet dies, not by fading away but by collision, by transformation into energy and heat and chaos. Other comets, called sun grazers, pass so close to the sun that they evaporate entirely, their ice boiling away in hours, leaving only dust and memory. These are the most dramatic deaths, the ones where the comet literally ceases to exist as a solid object. They approach within a few million kilometers of the sun's surface, sometimes even closer, diving through the sun's corona, where temperatures reach millions of degrees. At that distance, the heat is unimaginable. The ice doesn't melt. It doesn't even sublimate in the normal sense. It simply flashes into vapor, explosively, violently. The dust that held the ice together is released all at once, creating a bright cloud that glows intensely for a few hours and then disperses, scattered by the solar wind, pushed outward into space. These sun grazers are often discovered by satellites that monitor the sun. The Solar and Heliospheric Observatory has found thousands of them, tiny comets, most no more than a few meters across, plunging toward the sun and vanishing. They are seen once, blazing bright, and then they are gone, absorbed into the light that destroyed them. Some astronomers believe these tiny sun grazers are fragments of much larger comets that broke apart centuries or millennia ago, each piece following roughly the same orbit, arriving at the Sun weeks or months or years apart, the remnants of a single ancient traveler, now scattered across time. But it is not sad. It is transformation. The comet does not end. It becomes something else. Gas, dust, light. It joins the solar wind. It drifts outward. It becomes part of the space between stars, part of the quiet fabric of the cosmos. The atoms that once formed the comet's ice and rock are released, free to wander, to eventually join other clouds of gas and dust, perhaps to form new stars, new planets, new comets. Nothing is truly lost. Everything changes form. There is a certain poetry in this. A comet that has existed for billions of years, unchanged, frozen, can be undone in hours by heat and stress. But in that undoing, it becomes part of something larger. It releases the water and organic molecules it has carried since the birth of the solar system. Those molecules drift through space, riding the solar wind, perhaps eventually reaching a planet, perhaps contributing to an atmosphere, an ocean, a possibility of life. The comet's death is also a gift, a final act of generosity, releasing everything it held back into the universe. And as you let go of the day, let go of tension, think of this. Sometimes to become light, you must let go of form. Sometimes transformation is the only way forward. The comet teaches us that endings are not really endings at all, but changes, transitions from one state to another. What seems like destruction is actually release, the letting go of what we were so we can become what we will be next. The comet held its form for billions of years, but when the time came, it let go. And in letting go, it became light, became freedom, became part of everything rather than just one thing alone in the dark. We have sent spacecraft to visit comets up close for most of history. Comets were mysteries. We could see them, admire them, fear them, wonder about them, but we could not touch them. We could not know them, not truly. They appeared in the sky, glowing and mysterious, and then they left, and all we could do was watch and speculate and wonder. Were they made of ice or fire? Were they solid or gaseous? Were they smooth or rough? We could observe their tails, measure their brightness, calculate their orbits, but we could not answer the simple question of what a comet actually is. Not with certainty, not with the confidence that comes from direct experience. But in recent decades that changed. Humanity reached out, carefully, quietly, and touched the ancient travelers. We built machines, packed them with instruments, launched them on journeys lasting years, sent them across millions of kilometers of empty space to rendezvous with objects moving at incredible speeds, objects that had never been visited, never been seen up close, never been touched by anything except the vacuum of space and the light of distant stars. In 2004, the Stardust mission flew through the tail of Comet Wild 2, collecting tiny grains of dust and returning them to Earth. This was an extraordinary achievement. The spacecraft had to navigate to a precise point in space, at a precise time, traveling at tremendous speed, fast enough that the dust particles it collected hit its capture material with enough force to bury themselves deep inside. Scientists studied those grains and found minerals that had been formed near the Sun, mixed with ice from the outer solar system. The comet was a mixture, a traveler that had seen both fire and frost, that contained material from different regions of the early solar system, all jumbled together, preserved in frozen silence for billions of years. The dust grains were tiny, some no bigger than bacteria, but they told enormous stories. They contained pre-solar grains, materials older than the Sun itself, left over from previous generations of stars that had exploded and scattered their contents into space. They contained organic molecules, complex carbon compounds, the building blocks of life. They contained crystalline minerals that could only have formed at high temperatures, yet they were found in a comet that had spent billions of years in the deep freeze of the outer solar system. The comet was a museum, a library, a time capsule containing evidence of the solar system's entire history. In 2014, the Rosetta spacecraft arrived at Comet 67P, a strange duck-shaped nucleus tumbling slowly through space. This mission was even more ambitious. Rather than flying past, Rosetta entered orbit around the comet, becoming the first spacecraft to orbit a comet, to stay with it, to watch it change over time. For 2 years, Rosetta orbited the comet, watching it wake as it approached the sun, watching jets of gas burst from its surface, watching it change day by day. The spacecraft's instruments measured the composition of the gas, mapped the temperature of the surface, analyzed the dust, photographed every feature in stunning detail. The comet was bizarre and beautiful. Its surface was rough, covered in boulders, cliffs, smooth plains and pits. Some areas were bright, others dark. Jets of gas erupted from specific locations, sometimes lasting for hours, sometimes for just minutes. The comet was active, dynamic, alive in its own strange way. It even sang, emitting oscillations in its magnetic field that could be converted to sound, a deep, eerie humming that scientists recorded and played back, the first time anyone had heard a comet's voice. Rosetta even sent a small lander, Philae, down to the surface. The landing was dramatic. The lander's harpoons failed to fire, and in the comet's weak gravity, Philae bounced, rose hundreds of meters into space, drifted for 2 hours, and then came down again, bouncing a second time before finally coming to rest in the shadow of a cliff. The lander's solar panels were mostly in darkness, limiting its operational time, but for the hours it had, Philae worked, drilling into the surface, analyzing the ice and dust, sending back photos from the surface of a comet, the first time humanity had ever stood, even remotely, on such a world. These missions were quiet. No explosions, no drama, just patience, precision, and wonder. They taught us that comets are more complex, more varied, more beautiful than we imagined. They are not simple teetle snowballs. They are worlds, small and strange, each one different, each one precious. They have landscapes, weather in a sense, seasons as they approach and recede from the sun, geology shaped by sublimation and temperature rather than by water and wind. And as your breathing slows, as your muscles relax, picture this: a small machine floating beside a comet, far from home, watching in silence, sending whispers back across the dark. We are curious. We are reaching. We are learning. These spacecraft are our ambassadors, our eyes and hands reaching into places we cannot yet go ourselves, touching the ancient and the mysterious, bringing back knowledge, bringing back images, bringing back proof that the universe is knowable, that mysteries can be solved, that patience and ingenuity and curiosity can carry us anywhere we dream of going. Comets have inspired wonder and fear throughout human history. For as long as humans have looked up, comets have been there, appearing without warning, blazing grise the heavens, lingering for weeks, and then vanishing. Ancient peoples did not understand them, they could not predict them, and so they feared them. Comets were seen as omens, warnings, messages from the gods, signs that the natural order had been disturbed, that something significant was about to happen, something that might change the world. The appearance of a comet might signal the death of a king, the coming of war, or the fall of an empire. In medieval Europe, comets were called hairy stars because of their long streaming tails that resembled flowing hair, and their arrival brought dread. People saw them as harbingers of plague, famine, disaster. When a bright comet appeared in the sky, prayers were said, rituals performed, sacrifices offered, anything to appease whatever divine force had sent this warning. The comet was a messenger, and the message was rarely interpreted as good news. In China, they were recorded carefully, their paths and brightness noted in chronicles that stretch back thousands of years. Chinese astronomers were meticulous observers, documenting every comet they saw, describing its color, its position among the stars, how long it remained visible, whether its tail pointed north or south or east or west. These records are valuable to modern astronomers, providing a historical record of comet appearances stretching back more than 2 millennia, helping us understand the orbits of periodic comets and track how they've changed over time. But comets also inspired awe. In 1066, a bright comet appeared in the sky, later known as Halley's Comet. It was seen as a sign of great change, and indeed that year, William the Conqueror invaded England, defeating King Harold at the Battle of Hastings and changing the course of English history. The comet was woven into the Bayeux Tapestry, a thread of light in the fabric of history, depicting over the scene like a divine witness to human affairs. People didn't yet understand that the comet had nothing to do with earthly events, that its appearance was determined by orbital mechanics, not by divine will. They saw correlation and assumed causation, saw the comet and the invasion happening in the same year, and assumed one caused the other. As science grew, fear turned to fascination. Edmund Halley in the 1700s realized that comets were not random omens, but predictable travelers, returning on schedules that could be built using Newton's laws of motion and gravity. He studied historical records of comet appearances and noticed a pattern. Bright comets had appeared in 1531, 1607 and 1682, roughly 76 years apart. He proposed that these were not three different comets, but the same comet, returning periodically, and he predicted it would return again in 1758. He predicted the return of the comet that now bears his name, and he was right, though he did not live to see it. When the comet appeared on schedule in 1758, 16 years after Halley's death, it was a triumph for science, proof that the heavens followed laws, that comets were natural objects, not supernatural warnings. This changed everything. Comets went from being feared to being celebrated. When Halley's comet returned in 1835, people threw parties. When it returned in 1910, millions gathered to watch, though some feared the Earth would pass through its tail and be poisoned by cyanogen gas that spectroscopy had revealed in comet tails. Entrepreneurs sold comet pills to protect against the anagen threat. But most people simply watched in wonder, no longer afraid, now curious, excited to witness a celestial event that happened only once in a human lifetime. Today, we no longer fear comets. We chase them with telescopes and spacecraft. We name them, study them, celebrate them. Amateur astronomers scan the skies hoping to discover a new comet and have it hit after them. Professional astronomers use comets to study the early solar system, to understand how planets formed, to learn about the distribution of water and organic molecules in space. They are no longer omen. They are teachers, storytellers, reminders that the universe is vast, ancient, and full of wonders. We are only beginning to understand, and now, with the final fact softly settled into place, let the universe grow quiet around you. We've wandered through the frozen edges of the solar system, through trails of light and ancient ice, through time itself. We've watched comets break and reform, deliver oceans, and inspire civilizations, and through it all, a single truth echoes gently beneath the surface. The universe is patient. It does not rush. It moves in long, slow orbits, in cycles measured not in days but in heaven. And you, right now, are part of that stillness. You are made of stardust and comet ice, of atoms forged in distant suns and delivered by ancient travelers. You are the universe, resting, breathing, dreaming. Sleep well, gentle traveler, and thank you for drifting with us through the quiet wonders of the cosmos.